So here's a trig problem that's kind of tough. It's one of the tougher sine, cosine, tangent ones where you're still involving just right triangles. The popular description is like this h might represent the height of a tree, and this x here would be like the width across a river. And so here you are on the other side of the river, and so you measure this distance to be 210 feet from that to the back side of the river. And then you measure from that spot, you measure the angle from there up to the top of the tree. And you also do the same thing from the edge of the river. All right, so you got all this information. Anyway, we're going to go ahead and solve for the distance across the river, the height of the tree, and while we're at it, we can go ahead and solve for this angle y here. So hopefully you see our large right triangle here. So we've got angle 28 and angle 70 that are the only two angles we really know. We're going to use that to relate them to the height of the tree and the distance across the river. So to start, I'll start with tangent of 70. All right, tangent's equal to opposite over adjacent. So that's going to be h over x. And I could solve for either variable here. I'm going to go ahead and solve for h because that's the easy one. So h would equal tangent of 70 and then times x. H would equal tan 70 times x. All right, let me do something similar here with tangent of 28. So tangent of 28 is going to be opposite over adjacent. So that's going to be h over the adjacent side is this whole side here. So that's going to be x plus 210. All right, so I've got two equations here, two equations that involve x and h. So I'm going to use those to solve for x and h. All right, so because we've already got, we've got h is equal to this right here, I'm going to go ahead and substitute that in. Actually, I tell you what, I'm going to multiply this equation. I'm going to solve for h. So I'm going to multiply by x plus 210 on both sides. X plus 210. So that cancels with that. And so I end up with h equals tan of 28 x plus 210. All right, so now I've got two equations here that are both equal to h. And so that means I can go ahead and set these equal to each other. And that's going to allow me to solve for x here. So tan 70, x tan 70, I guess I could call it that. So x tangent of 70 is going to equal this one because these were both equal to h. So I'm just going to set them equal to each other. I'll put that in red. Tan 28. All right, and then times x plus 210. So what I'm going to do here is I'm going to go ahead and distribute the tan 28, and then I'm going to move my x's all to one side. So distribute the tan 28. Now you could have made tan 70 and tan 28 into decimals. I really prefer leaving them as the trig function that they are. Plus 210 tan 28. All right, and now I'm going to minus this tan of 28 from both sides. So minus this one, so minus times x minus tan 28 times x. All right, so I'm going to have x tan 70 minus x tan of 28 equals 210 tan of 28. At this point, if you wanted to make these into a decimal, you could, and then just combine terms because they're both going to be like terms. What I'm going to do is, because they both have an x, I'm going to factor out the x. All right, this is similar to converting them to decimals, but this is avoiding that combining like terms thing. So if I factor out an x, this one becomes tangent of 70, and this one just becomes tan of 28. All right, is equal to 210 tan of 28 still. And then what we're going to do to solve for the x is divide both sides by the tan 70 minus tan 28. So divide by tan 70 minus tan 28. All right, so when you divide it on this side, it just cancels. All right, so you get x equals that. All right, now I'm going to go ahead and make it into a decimal here. All right, so I've got 210 tan of 28, and on the bottom I've got tan of 70 minus tan of 28. All right, now that's equal to x, so 50.39, I'll call it. So x equals 50.39. You could store that to x if you wanted to, but so I'm going to go back up here, and I could use this equation and plug in 50.39 for x, or I could do it here. I'm just going to do it up here because it looks easier. So 50.39 times tangent of 70. All right, so that gives me h. So the height of the tree was 138.45. So if you wanted the the total distance, you could just do 50.39 plus the 210. All right, you got the height of the tree. That's 138. The only thing we didn't solve for here was this y there. That was actually really easy. So 70 and this angle are supplementary. So this one has got to be 110 degrees. And then you can take 180 minus that one, and that's going to give you your missing angle there. Minus 110 minus 28, and you get 42 degrees. Okay, so that solved everything we were looking for. Woo. Now, if you just had to know, you could also find this distance here. All right, you could use, a sine of 28 if you wanted to. Sine of 28 would be h over this missing side, because you already know what h is. Or you could use the Pythagorean theorem. H squared plus whatever this side is squared equals that squared. All right, that's good.